Okay, synthetic division of a cubic polynomial. So now the leading coefficient is not 1, so that means you have a longer list to choose from of potential roots. And you're going to have, of course, fractional ones because you're going to end up having a ratio of these roots over these roots, right? Numerator, denominator. Okay, so find roots of the function. So because the leading coefficient is not 1, take the constant, and so do your factor tree. 1 and 25, 5 and 5. Okay, so 1, 5, and 25 are my possible roots, right? Okay, because the leading coefficient is not 1, you got to take the 2. And so 2 is just 1 times 2. And so this is plus minus 1, plus or minus 2. Okay, so this is your big long list, right? Okay, so far I have plus or minus 1, I have plus or minus 2, I have plus or minus 5, and I have plus or minus 25. Okay, so this is the roots from both of these that makes up the original list. After that, you're gonna have a ratio, right? Remember, it's your constant over your leading coefficient roots, right? So, okay, so 1 over 1 is still 1, 5 over 1 over 1 is still 5, 25 over 1 is still 25. Okay, but now the 2 is going to make fraction, fraction, fraction. Okay, so plus or minus 1, plus or minus 5 halves, plus or minus 25 halves. Okay, so this is your potential. These are your possibilities. Can I spell that? Okay, so these are your possibilities of the roots, right? And remember, the reason why you have 5 halves and 25 halves, one of these is going to work, right? I'm thinking it's probably this one. This is probably going to be one of the one that works. I just don't know if it's positive or negative. Because remember, if you have 5 halves, this equates to 2x plus 5 and 2x minus 5. One of these is going to be the factor for this, okay? I think so. Right, 25, like that's just 2 and 25. That just seems way too high because the numbers would be so large. If you guys really understand expanding and how when you expand and you see the numbers, that 25 is way too high. Like for sure, I already know that's an out, right? Okay, so now when you come to here, even this 25, it's just way too high. The numbers don't act that way. So I even think that this one is out, right? So really it's the 1, 2, 5. That's really what you're looking for. And this is a repeat, so, you know, I wrote it, but it's not a big of a deal. Okay, so again, same thing. Make sure you write it the correct way the first time. So 2, negative 13, positive 10, and 25. 2, negative, positive, positive. All right, so let's synthetic divide. So let's just take positive 1, right? Okay, bring down the 2. 1 times 2 is 2. Negative 11. 1 times negative 11 is negative 11. And then I get negative 1, and already it's a fail, so move on. So let's do negative 2. 2, negative 13, 10, 25, right? And the reason why I didn't continue is because my remainder is not 0. Remember, it must be 0. It has to be 0 for the value to be a root. If it's not 0, it's a fail. Whoops, sorry. Okay. All right, so then you have, okay, so let's bring it down. 2, negative 2, I hope I don't mess up because I don't have anybody here to like tell me. Negative 15, I think this is gonna be it. Positive 15, yeah, this is it. 25, negative 1 times 25 is negative 25, and so there we go, yay. Okay, this is a root, right? Because my remainder is 0, so yay, that's it. Okay, so negative 1 is a root, correct? Because I got that 0. When you get the 0, that means winner, okay? So that means so far, x is equal to negative 1, which equates to x plus 1 as a factor form. So that means the other factor, as of now, that's not factored, is remember, if it's a cubic, how much can you see? Oh yeah, it's a cubic, so remember that's x to the cubed, right? So there's x3. If that's a 3, this goes down an exponent or a degree. So this is x2, x1, and this is my constant. So this is 2x squared minus 15x plus 25. And so now you have to find roots here. Okay, so it's up to you. You can still synthetically divide if you would like, or you can just keep going. It's up to you. All right. Okay, so as far as here, I don't think it's going to be the 2. I know it's one of these, but what's the third one? I'm thinking it's like a 5. So I'm going to go with plus minus 5. Okay, so if I try out the 5, right, so I'm coming to negative 15, 25. So I'm going to do the positive 5 first, and then I'll be the negative 5. Sometimes I kind of don't know which one, positive or negative, but usually I kind of have an idea just from the numbers. Because if you expand it quite a bit and you've paid attention to the numbers, you kind of have an intuition. Okay, so let's bring it down. 5 times 2 is 10. Negative 5, negative 25. Oh, hey, there we go. All right, and so I'll do negative 5 too, just to show us get rejected. All right, and so yay, there's my other remainder, right? Okay, so remainder is 0. There's my other root. So that means, I don't want to mess you guys up and keep going. Okay, so then that means this is positive 5. And so what does that mean? Okay, my x plus 1 is from up here, right? Right, because I got the 0, yay. All right, so I get x plus 5, which means it's x minus 5. Okay, so what's your third? It's here. Remember, if this was a 2, right, because that's x squared, this is an x, and this is now my constant. So that means this is 2x minus 5, right, because this is 2x minus 5 would be that factor. Okay, so then if you zero product property that, can you see? 2x minus 5, right? Add the 5 over, 2x is equal to 5, divide by 2, and so I get 5 halves. And so there's your answer. So I had an idea it was a 5 halves, but yeah. All right. Okay, here we go. So I'll give you guys practice with cubics with leading coefficient 1 and leading coefficient not 1, but it's just setting up the numbers. Watch your signs. That's it. And then the other thing is, once you get your quotient, your coefficient, right, of your quotient, make sure you write that out, and you just have to decide whether you synthetically divide or if you factor it. Okay. All right. Yay. Let's turn this off.